This is the best healthy alarm clock you'll ever need, and I'm going to show you how you can make it in your garage. It is far healthier to wake up with light than sound, so that's what I'll be leaning into today. Let's make up some plans and get started. I drew up my design, and it looked like this. Hold on, before we get started, this was a project I did for school, and this was the first prototype. Yeah, not great. So we're going to build this starting from nothing and rebuild it from the ground up. First up, you're going to need this, a NEMA 17 stepper motor. It has enough torque to supply for any curtain, and it's nice and cheap. I'll put everything you need in the description of this video, so don't worry about it. Next up, you're going to need a driver. This is an A4 988 driver, and you're going to need this because the Arduino can't drive it by itself. It just doesn't have enough power. But this thing is really cheap, about $1. You'll also need a pack of jumper wires, a 100 millifarad capacitor, and an Arduino and breadboard. I had all of this from an Arduino starter kit, so I would recommend getting that, but it's a little more expensive, but you can do many more projects with it. But that means it was time to open my computer, put on headphones, and lock in the long process of coding. Which just means telling Claude to do everything for me, because AI has to be useful for something. So it spit out the code, which means it was time to do the mechanical side. My plan was to use 2 pulleys on the outside of the curtain and put a spindle attached to the motor that the thread can wind up into, pulling the bottom 2 pieces and opening the curtain, using pulleys for less friction. Next up, wire up all the electronics. I was using this power supply that came with the Arduino starter kit. However, this did not have enough voltage, so I exposed the wires to the plug-in to the Arduino so I could directly wire it into the breadboard. Now it's time to plug it in and test if it works.
Sorry to interrupt, but please, I have a small channel. Leave a like, subscribe, and leave a comment on what projects or videos you want to see in the future. It helps a lot, and I'll read all of them. Back to the video.
Yeah, it didn't work at all. I figured out I fried the driver, so I needed a new, beefier one. This is the DRV8825, and it's just as cheap as the other one. So let's wire this one up and test if it works now. But I could just not seem to get my electronics to work, whether it was the code or the wiring. But I finally did, and here's the final wiring. I added a capacitor and wired it directly into the wall, and also triple checked my wiring just to make sure, but it was the driver. Now, here's my wiring diagram. Ignore this white piece, it's not supposed to be there. Act like it's not there. Also, the 100 UF thing is the capacitor. Use the 100 or else you'll have a rather explosive project. What does a capacitor actually do? We are converting alternating current from the wall to direct current into the Arduino. The capacitor will smooth out voltage spikes that could fry anything in our board. This is how it looks. The longer end is the positive end, so make sure you plug it into there. Now that it works, let's connect everything, including the mechanicals. Time to finally try it on the window and open our curtains. Which means
Showtime, folks.
the code works, but it's really, really loud. This defeated the whole purpose of waking up with light. So, time to go back to the drawing board and research what I can do to stop these vibrations. Ray wanted to help, and she did. And I found these. Yeah. These are made out of silicone. Silicone is a rubbery material if you're not familiar, but we're using silicone because a vibration is like a wave, and it transfers this wave into any object with the same frequency. So, a rigid object would move at the same frequency back and forth as the wave, up and down, side to side, same thing. But when you use a softer object, that vibration is absorbed and dispersed among many different directions, which means many different smaller force arrows in my drawing, thus killing the overall impact. Now let's put these between the motor and see how it works. These worked great, much quieter, much better for waking up. Now let's attach it to the curtains for real and see if it can work. Yeah, the motor wasn't pulling it at all. It was just too heavy. And the motor shaft was just spinning freely inside the hole I made for it. So I added another nail to try to clamp it onto the motor shaft. But this also didn't work. It still spun freely, and the curtains obviously didn't open. So out of ideas, I had to go to somebody.
What do you think, huh? What do you think?
Correct, Ray Ray. This is a mounting hub, and it works perfectly. I can just clamp it onto the motor so it can't spin freely, and screw it onto our spindle. I didn't have screws for this thing though, so I'm just going to use Legos with these little studs as washers and put it onto this new, beefier laundry cap head. This is how the final product ended up looking. Not too bad. And this is how it worked. So here is the final prototype for the curtain opener.
And that is your healthy DIY alarm. Stay tuned for more, and thank you for watching.